In this video, we're going to look at cubic sequences and an alternative method for finding the general term. This method is very similar to the approach in the alternative method video for the quadratic sequences. So before watching this one, you should watch that video so that you have an idea of what's going on. Also, the cubic sequences, the other method, is also a good idea to watch. And in that video, we saw that for any cubic sequence, un equals an cubed plus bn squared plus cn plus d, the value of a is always equal to 1/6 of the third difference of the sequence. And that's going to be really important for the method we're going to see in this video. So let's have a look at two examples. The first one is -6, -4, 10, 42, 98 and 184. Whenever we see a sequence, the first thing we do is we're looking for differences. So the differences here, the first difference is 2, and then 14, and then 32, 56 and 86. The second difference, we've got 12 and 18 and 24 and 30, and finally the third difference, 6, 6 and 6. So the third differences are all the same, so we are indeed dealing with a cubic sequence. And if we have a cubic sequence, the third difference, and a is equal to 1/6 of that. So in this case we know that a is equal to 1. Now what we're going to do is we're going to take our original sequence, and I'm going to create a copy of it down here. That is un, and underneath it we're going to write what we got from here, which is with a equals 1, so that's 1 times n cubed. That is 1, 8, 27, 64, 125 and 216. Now we're going to do un minus n cubed. And by doing this subtraction, we remove the cubic part from our original sequence. So -6 minus 1 is -7, -4 minus 8 is -12, -17, -22, -27, and finally -32. Now we look at the differences, and we have -5, -5, -5, all the way through. The first difference now for this sequence is -5. So what that means is that the green sequence has general term -5n because it's linear, and then to get from the -5 to the -7, the first term, it's -2. So putting that all together, we have un is equal to, well, a was 1, so n cubed, and then we had this linear part, -5n minus 2. So the general term is n cubed minus 5n minus 2. In this example, we have the sequence 17, 59, 143, 287, 509 and 827. Once again, we find the differences, and we have 42, 84, 144, 222 and 318 as the differences, the first differences. The second differences, we've got 42, we've got 60, we've got 78 and 96, and finally the third differences are 18, 18, 18. The third differences are all the same, so we have got a cubic, and also A is equal to 1/6 of the third difference, so A is equal to 3. Now once again, we take a copy of our original sequence, UN, and from that we're going to subtract 3n cubed, because A is 3. We know we have 3n cubed in our general term, so we're going to take away that from our sequence. Now 3n cubed is equal to 3, 24, it's 3 times 3 cubed next is 81, 3 times 4 cubed is 192, 3 times 5 cubed is 375, and 3 times 6 cubed is 648. Now we do the subtraction to remove the cubed part, and we get 14, 35, 62, 95, 134 and 179. So now we're dealing with this red sequence, and once again we look at the differences. We have 21, 27, 33, 39 and 45, and then we look at the second differences, which are 6, 6, 6 and 6. So the second differences of this sequence are all 6. So that means we have a quadratic. So the n squared term, well, b is what's multiplying the n squared term, so b is equal to 3, because when we're looking at quadratic sequences we have to half the second difference. So now we have a is equal to 3, and we have b is equal to 3 as well. But now we have to carry on, and we have to write un, which was our red sequence above, so that's 14, 35, 62, 95, 134 and 179, and from that we need to subtract, well, b is 3, so it's 3n squared. So 3 times 1 squared is 3, 3 times 2 squared is 12, 3 times 3 squared is 27, 3 times 4 squared is 48, 3 times 5 squared is 75, and 3 times 6 squared is 108. Once again, we do the subtraction, removing the quadratic, the squared term, from our original sequence. So 14 minus 3 is 11, and we get 23 next, then 35, 47, 59 and 71. Now we find the differences of this sequence here, and that is 12, 12, 12, 12 and 12. So this time we've got a linear sequence because the first difference is 12, and the linear sequence is 12n, and then we need to get from 12 to 11, the first term is minus 1. So putting this all together, we have un is equal to, well, first of all, we had our a equals 3. So going back, we have 3n cubed. Next, we had b equals 3. So we have plus 3n squared, and finally we have this section here plus 12n minus 1, giving us our general term for this cubic sequence. So what we have to do is find the value of a and then subtract this from the original sequence to remove the cubic part of the sequence. We then get a new sequence which we then have to analyze in a similar way. We might have to subtract a quadratic part as well until we finally get to a linear sequence. Once we have all the different parts, we piece them back together to come up with the general term for our original sequence.